Today, we are going to discuss integrating trigonometric functions. So to start with, I'd just like to show the next slide, which is the guidelines for evaluating integrals involving powers of sine and cosine. So we have number one, if the power of the sine is odd and positive, then save one sine factor and convert the remaining factors to cosines. Then expand and integrate. So the integral of sine to the power of 2k plus 1 of x times cosine to the power of n of x dx is equal to the integral of sine squared x to the power of k times cosine raised to n of x times sine x dx. So the meaning now of sine squared x, the integral of 1 minus cosine squared x to the quantity of that, then raised to the power of k, times cosine to the power of n of x times sine x dx. For number 2, if the power of the cosine is odd and positive, then save one cosine factor and convert the remaining factors to sine. Then expand and integrate. So the integral of sine to the power of m of x times cosine to the power of 2k plus 1 of x dx is equal to the integral of sine to the power of m of x times cosine squared of x, the quantity of that is raised to the power of k, times cosine of x dx is equal to sine to the power of m of x, and then you replace now the meaning of cosine squared x, which is now 1 minus sine squared x, the quantity of that is raised to the power of k, times cosine x dx. And for number 3, if the powers of the sine and cosine are even and non-negative, then make repeated use of the identities. So for sine squared x, we use 1 minus cosine 2x all over 2. And cosine squared x is equal to 1 plus cosine 2x all over 2 to convert the integrand to add powers of the cosine. Then proceed as in guideline number 2. So let us use these rules in the succeeding examples. Okay, for number 1, so the integral of cosine x times sine to the power of 5x dx. So I will solve that one using, I will let u as sine x. So u is equal to sine x and du is equal to cosine x dx. So since the du is visible in our given, so rewriting the given in terms of u and du, so we can write now as u raised to 5 times the meaning of cosine x dx is du. So therefore, we have the integral of u raised to 5 du. And now integrate using the power rule. So we can write now u raised to 6 over 6 plus a constant. So therefore, we have now sine to the power of 6 of x over 6 plus a constant. So that is now the answer of number 1. For number 2, we have the integral of sine to the power of 6x and cosine cube x. So to solve for that, we are going to factor cosine cube x in terms of cosine squared x times cosine x. So rewriting the given, we can write now as sine to the power of 6x times cosine squared x times cosine x, which is the factor now of cosine cube x dx. And then we are going to use the identity of cosine squared x from the Pythagorean identity. So we can rewrite now the given as sine to the power of 6x times 1 minus sine squared x times cosine x dx. Okay, after rewriting the given, so we can let now u as sine x. Then du now becomes cosine x dx. So as you can see, the du is visible now in our given. So rewriting the given now in terms of u and du, so we can have now as u to the power of 6 times 1 minus u squared times du. Then, by using the distributive property of multiplication, so we can write now u raised to 6 minus u raised to 8 times du. So by integrating now using the power rule, so we can write u raised to 7 over 7 minus u raised to 9 over 9 plus a constant. And then we're gonna change now our u in terms of sign. So therefore we have sine to the power of 7 of x over 7 minus sine to the power of 9 of x over 9 plus a constant. So that's now the answer for number 2. Okay, for number 3, we have the integral of sine to the power of 5 of x dx. So in this kind of example, we're going to factor out the sine to the power of 5 of x. In a way, we are going to save 1 sine of x. So we can write now as sine to the power of 4 of x times sine of x dx. But since this one is has a power of 4 and that can be factored and can be written as sine squared x and then quantity to that raised the power of 2 times sine x dx. Now, the sine squared x there can be written as using the identity 1 minus cosine squared x and quantity to that raised the power of 2 times sine x dx. And then from there, we're gonna write now u as cosine x and du is equal to negative sine x dx. So since the visible du there is only sine x dx, therefore we have a coefficient factor of negative 1. So I will write now there as negative 1 as negative to the integral of 1 minus u squared. So the quantity of this is raised to the power of 2. Then the sine x dx now can be written now as du. So the integrand has the square of 1 minus u squared that can be expanded as 1 minus 2u squared plus u raised to the power 4 du. And after that, we are going to integrate. So the negative of u minus 2u cubed over 3 plus u raised to 5 over 5 plus a constant. And then we're going to rewrite now the meaning of u, and at the same time, we're going to multiply the negative 1. So we can write now the negative of cosine of x, negative times negative 2/3 becomes now positive, positive 2/3 of the meaning of our u is cosine cube x. Negative times 1/5 of u raised to 5 can be written as to the negative 1/5 of u raised to 5, which is now cosine to the power of 5 of x plus a constant. Okay, so that is now how to answer number 3. Next, we have number 4. So the integral of sine squared x cosine squared x dx. So we are going to use the half angle identity to solve this problem. So we can write now as we have the integral of 1/2 times 1 minus cosine 2x times 1/2 of 1 plus cosine 2x dx. So multiplying the two terms, so the numerical coefficient now we have 1/4 times the integral of the product of 1 minus cosine 2x times 1 plus cosine 2x. So will give us the product of 1 minus cosine squared 2x dx. Next, we have 1/4 the integral of 1 minus, we are going to use again the identity of cosine squared 2x using the half angle identity. So this is now 1/2 times 1 plus cosine 4x because of twice the angle is 2x, so it becomes now 1 plus cosine 4x of dx. Next, I'm going to use distributive property and I will separate the two terms so that it will not be confusing. So therefore, we can write now as 1/4 the integral of 1 dx minus 1/4 times 1/2. We have now 1/8, the integral of 1 plus cosine of 4x dx. And then the integral of the first term, we have 1/4 of x minus 1/8 times the integral of 1 plus cosine x. We can write now as x plus 1/4 of sine 4x plus a constant. So multiplying this, the second term, so we can write now 1/4 of x minus 1/8 of x minus 1 over 32 of sine to the power sine of 4x plus a constant. But the first two terms are similar terms, so we subtract 1/4 of x minus 1/8 of x, so gives us a difference of 1/8 of x minus 1 over 32 sine 4x plus a constant. So that is now the answer for number 4. Okay, so but I can also present another solution aside from this. So I will just show here in the next slide. Okay, the integral of sine squared x cosine squared x dx can also be solved using this, the integral of sine x cosine x. So the quantity of this will be raised to the power of 2 dx. And then using the half integral formula of sine x cosine x, so we can write now as 1/2 of sine 2x and then quantity to the power of 2 dx. Simplifying this one will give us 1/4 the integral of sine squared 2x dx. Now we are going to use again the half integral formula of sine squared 2x. So this can be now written as 1/4 times the integral of 1/2 times 1 minus cosine of twice the integral. So we have 2 times 2x gives us 4x dx. So by multiplying this one, we can write now 1/4 times 1/2. We can write 1/8, the integral of 1 minus cosine of 4x dx. So integrating that one will give us 1/8 of x minus 1/8 times 1/4 of sine 4x plus a constant. So we have now 1/8 of x minus 1 over 32 of sine 4x plus a constant, which is now the same answer to our previous solution. Okay, number 5 is the integral of sine cube x dx. So in this case, we will factor the sine cube x as sine squared x times sine x. So I will write now as sine squared x times cosine to the power of 4 of x times sine x dx. So from there, I'm going to find that we're going to rewrite or the identity of sine squared x. This can be written now as 1 minus cosine squared x, the quantity of that, times cosine to the power of 4 of x times sine x dx. So from here, we're going to write u as cosine x and du, the derivative of cosine is negative sine x dx. So we only have sine x dx, so therefore I'm going to write the coefficient factor of negative 1. So rewriting the given in terms of u and du, so I can write now as the negative of the integral of 1 minus u squared times u to the power of 4 times du. So by using the distributive property, so we can write now 1 times u raised to 4 is u raised to 4 minus u raised to 6 du. So by integrating that one, we have the negative of u raised to 5 over 5 minus u raised to 7 over 7 plus a constant. So therefore, this is now negative 1/5 of cosine to the power of 5 of x. Negative times negative 1 over 7 becomes positive 1 over 7 of cosine to the power of 7 of x plus a constant. In number 6, so the integral of cosine cube x over the square root of sine x dx, so we can rewrite that one as cosine squared x times cosine x all over the square root of sine x dx. So we are going to write the identity of cosine squared x as 1. Okay, the identity of cosine squared x is 1 minus sine squared x. 1 minus sine squared x, quantity to that, times cosine x dx all over the square root of sine x. Then we're going to let u equals sine x, then du equals cosine x dx. So since du is visible in the given, so we can write now as the integral of 1 minus u squared times the meaning of cosine x dx is du all over the square root of u. Or this can be rewritten as the integral of 1 minus u squared times u to the power of negative 1 half du. And then by multiplying, so we can write now u to the power of negative 1 half minus u to the power of 3 halves du. By integrating, so we can write now u raised to 1 half over 1 half minus u to the power of 5 over 2 over 5 over 2 plus a constant, or that can be written now as 2 times u raised to 1 half minus 2 over 5 of u raised to 5 over 2 plus a constant. And then we're going to substitute back the meaning of u, which is now 2. We have sine of x raised to 1 half minus 2 over 5 of sine of x raised to the power of 5 over 2 plus a constant. So that's now the answer of number 6. Okay, number 7, the integral of cosine to the power of 4x dx can be written as the integral of cosine squared of x, then raise the power of 2 dx. And then the identity of cosine squared x can be written as the integral of 1 half times 1 plus cosine 2x. And then this will be raised to the power of 2 again dx. So by simplifying, so we can write the integral now of 1/4 times the integral of 1 plus cosine 2x raised to the power of 2 dx. And then I will write 1/4 outside. So the integral now of the square of 1 plus cosine 2x can be written as 1 plus 2 cosine of 2x plus cosine squared of 2x dx. And then we have now 1/4. So the integral of 1 plus 2 cosine 2x plus rewriting again the identity. So we have now 1 half times 1 plus cosine of twice the angle. So we have now 4x dx. So I'm going to expand the third term. So we can write now 1/4 the integral of 1 plus 2 cosine of 2x plus 1 half plus 1 half of cosine 4x dx. Then after that, I'm going now to combine like terms. 1 plus 1 half equals 3 halves. So we have now 1/4 the integral of 3 halves plus 2 cosine of 2x plus 1 half of cosine 4x dx. So from there, we can now integrate. So we can write now 1/4 of 3 halves is 3 over 2x plus the integral of 2 cosine 2x can be written as 2 times 1 half of sine 2x plus the integral of the third term, we have 1 half times the integral of cosine 4x, we have 1/4 of sine 4x, and then plus a constant. So by combining like terms now, we can write as, we have now, I write first 1/4 times, we have 3 over 2 of x, 2 times 1 half of sine 2x can be written as sine 2x. Then the third term, we have 1 half times 1/4 of sine 4x can be written now as 1 over 8 of sine 4x plus a constant. And then we multiply 1/4 to each term. So therefore 1/4 times 3 halves, this becomes now 3 over 8 of x plus 1/4 of sine 2x plus 1/4 times 1/8. We have now 1 over 32 of sine 4x plus a constant. So therefore, that is now the answer for the integral of cosine to the power of 4 of x dx.